Awesome. This is a big week. This is one of those chapters in Algebra 1, guys, that you're going to spend a long time on, like 3 weeks probably, on a chapter like this. And we already did something like it a couple weeks ago, so our refresher is, what is this? What is a system? And then how do we solve it? So if you want to look back a couple weeks, you can. I'm going to go over it again right this second. But the idea is, this is the stuff where you have to find the x and the y, find the x and y that work in both equations. That's the ultimate goal. And there's 3 methods to do it. The one that we did a couple weeks ago was the graphing method. Remember, you graph the 2 lines, you see where they intersect, and you're done, okay? And then the 2 others that we're going to talk about today are substitution and elimination. Alright, cool. And so let's get started without further ado. I think you're going to like one of these other 2 methods that we do today. I promise y'all will like more than graphing because they're quicker and people just get tired of graphing. So if you're good at algebra, I think one of these 2 will be your favorite, and you'll get to decide which one's your favorite, and you'll get to use the heck out of it next year. Okay, so let's start with the substitution method. Now, we're going to write the actual steps down over here, and after we write it all out, then we will actually practice it over here on these examples. So I'm going to color code so that we can see what's going on in each step. Now, substitution, what does it mean to substitute? Well, think about, you know, I don't know if you play basketball or volleyball or any sport. If you are substituting a player into the game, what happens? Well, you take somebody out of the game and then you put somebody back into their place. We are going to do that exact same thing with math right now, and that's why it's called the substitution method. Okay, so here are the steps, and then we'll do the actual work. So step 1 is you need to choose one of the equations given. So choose one equation and isolate one variable. When we actually do the math, it's going to make more sense, but I just want us to write the process down right here. So we're going to choose one equation and isolate one variable. So in fact, you know what, let me go ahead and do that with this problem. And as we write each step here, then I'll do it on this one. Okay, so you choose one of your 2 equations. Now, it doesn't matter which equation you choose, either number 1 or number 2, but our ultimate goal is going to be to get one of the letters by themselves, one of the variables by themselves, so either the x or the y. Now, I am looking at this, and notice in equation 1, x and y are mixed on this side right here. But on equation 2, the y is already isolated. So for me, I would choose equation number 2. I would choose this because why? Because the y is already isolated. I don't have any work to do, which is fantastic. So there's me doing step 1. Now step 2. Step 2, what you want to do is substitute your step 1, okay? You're going to substitute your equation that you just did into the other equation and solve. Okay, so write it, pause if you need to, and then come back. I'm going to do that right now with this equation. So what does this mean? Substitute your equation into the other equation and solve. This is what I just chose, right? Now the equation is y equals 8 minus 3x. I'm supposed to somehow substitute this into the other equation. Well, the other equation is 2x plus y equals 6. And what the substitution's going to be is the letter that you got by itself. That's what you're going to substitute. So in this equation, notice how the y is by itself. So if y is by itself here, then I need to look for the y down here, which is right here. And what's going to happen is the substitution, okay? I'm going to take out the y, and I'm going to replace it with the equation that it's equal to. Okay, so the y's coming out because it matches this y, and in its place is going this 8 minus 3x business. So it'll look like this. I recopy the 2x, I recopy the plus sign, but the y comes out and all this mess comes in. And then I recopy the equals 6. So hopefully you can see that this substitution that's happening. Somebody goes out, somebody comes in. So I just recopied equation 2, took the y out, in its place plugged in this whole equation right here. Okay? Now what? Now it says to solve. So we just do our algebra. Okay, this is 2x plus 8 minus 3x equals 6. I get to drop the parentheses because there's no exponent, there's no multiplier, and now I just like solve. So 2x, I'm going to go ahead and group these together first because they're like terms. So what's 2x minus 3x? That would be a negative x. I recopy the plus 8. And now how do I get the x by itself? Because that's what we're doing. We just solve now. I need to subtract 8 from both sides. What's 6 minus 8? That would be a negative 2. And so that means x equals 2. Okay, so I've done all that work for step 2. Step 2 is the hardest step. Step 3, all you have to do now is use the number that you just found to solve for the other variable. Remember, these problems, if you remember from 2 weeks ago, they have an answer that is both an x and a y. In fact, we were writing our answer as a point. Okay, that's our goal. What's the x and what's the y? Well, we just found the x. The x is 2. Yay! Okay, so the x is 2, but I don't know the y. So the way that I find the y is I just take my x equals 2 and I plug it in anywhere up here and solve. Anywhere you want, okay? I usually plug it into the equation that I chose in step 1 just because it's sometimes easier. So I'm going to take this 2 and plug it in for this x. It says x equals 2, so plug it in there. So it's going to say y equals 8 minus 3 times 2. That is me doing my substitution. And 8 minus, so what would that be? 8 minus, so that would also be a 2. So I'm getting y is 2. So x is 2 and y is 2 for this problem. I'm going to do this one, you know, step by step so that you can see all of these steps in action at the same time. And hopefully it'll make a little bit more sense. Once you get this, you're going to get it, okay? But sometimes it takes a couple of goes at it before it makes any sense at all. Alright, so we're going to start back at step 1. So I'm going to choose one of the equations and I'm going to isolate the variable. So I don't care which one that you choose. I'm just going to choose the first equation because both of them are ugly. Okay, and now on this first equation, do you think it's easier to get the x by itself or easier to get the 3y by itself? I think it's easier to get the x by itself because there's no number in front of it. So if I want x by itself, then I need to take this guy and move it to the other side. And when I do that, I bring down this x. What happens with these? Well, they cancel. And then can I put these together, negative 1 minus 3y? I think not. One of them has a y and one of them does not. So it's just going to look like negative 1 minus 3y. You just recopy them both side by side. Okay, so there's my step 1. I chose one equation and I isolated one of the variables. Now, step 2. I need to take what I just did and substitute it into the other equation. So what's the other equation? Well, the other equation is right here. So it is 2x minus y equals 5. So now let me decide what to take out and what to plug in. Okay? Well, right here, all of this was my x. So down here, I need to be focused on the x because they have to match. This x comes out, and in its place goes all of this equation right here. This is the substitution being made. So a variable comes out, an equation goes in. So right behind the 2, x goes out, and all of that goes in. Then I recopy the rest. Notice I'd already recopied the 2 from above as well. So once I've done that, now it becomes a big ol' nasty algebra problem, okay? I need to distribute, negative 2 minus 6y minus y equals 5. So that's just distributing 2 times negative 1, 2 times negative 3y, okay? Now I'm going to put those together because they are like terms. So what is negative 6y minus 1y? That would be a minus 7y, I believe. Just be careful with all those negatives. There's a lot going on here with negatives. Now I'm trying to solve for y, so I need to move the 2 to the other side. Negative 7y equals 7. Now how do I get the negative 7 off of the y? I divide it off. So divide both sides by negative 7, and y equals negative 1. So I'm done with step 2. I told you it's the hardest, and sure enough, on this one, definitely the hardest. But I've got y is negative 1, so hooray. Now what? Now I need my answer to be a point, remember? So I've got the y part of the point, but I don't have the x part of the point. So what do? I do step 3, which is use the number you just found. So here's the number I just found to find the other number. So I'm going to take y equals negative 1. I'm going to come back up here. I like to go to, I already told you guys over here, I like to go to the equation I had in step 1. And that's where I usually plug it in. So I'm going to take a negative 1 and plug it in right here. Okay? So it's going to be x is this negative 1 minus 3 times y. Well, y is this negative 1. And then I math it out. So what would that be? Negative, okay, PEMDAS, let's multiply first. That's a positive 3. And so I've got a negative 1 and a positive 3. So I'm getting 2. So my final answer is that the x is 2 and that the y is negative 1. And remember what I just found here, folks, is if I take this x and this y and I plug them into both equations, you're going to get a true statement. True equations, they will both work. Now I've got some warnings. I've got no solutions and infinite solutions. There will be times where you're trying to do this substitution method and you may get something like you'll be working and you'll be like, okay, I'm doing math, and then you'll get to a point where your equation says like 2 equals 3. Okay, no. 2 does not ever equal 3. So if you end up with a statement where you get two numbers that are not the same and you're like, that's a lie. If that happens to you, you're going to answer no solution. Similarly, if you're working a problem and you get down to a statement where you've run out of x's and y's and you just have like 2 equals 2, and you're like, well, yeah, duh, 2 equals 2. If it's like a true statement or a does statement, then I would be like, oh, okay, well, if that happened, then this must have an infinite number of solutions. So, where did it go? It disappeared. Hold on. That was so weird. Okay, so if that happens to you, then don't panic. It just means that's how you're going to answer these problems, okay? It doesn't happen that often, but it may show up on the practice. So here's what I want you to do. We're 13 minutes in. But there's a whole nother method, and it's going to be too much information for you to do that all in one day. So you're going to hit stop. You're going to go to your homework, and you're going to try the section that says substitution, because that's what we were working on today so far. And you're going to try all those problems, okay? Or as many as you can, and then even watch the video of the solutions over those problems just to see like if you're doing it right, okay? Then you're going to come back tomorrow or the next day. You're going to come back tomorrow and you're going to finish. And when you go to YouTube to watch the video, you need to start at minute 15. And you'll start at minute 15 and you'll watch the rest of the video, and then you'll be ready to tackle the rest of the assignment, okay? So we will see y'all tomorrow. Okay, glad you are back. I hope it's not immediately or the next day, because that's a lot of info and I really want it to sink in. So hopefully you took some time off, preferably a whole day off, and now you're back for part 2. So here we go. Elimination method. This is another way, instead of substitution or instead of graphing, to do solving a system of equation. This is legit. This, I don't know how to spell favoritist, or even if it's a word, but we're going to pretend like it is. This is my favorite. It's for me, it is the easiest and it is the quickest. Now, I'm also pretty good at algebra, so, I don't know how you're going to feel. It's usually half and half. Half love substitution and then half love elimination. So, whatever works best for you. So, let's write the main idea or goal here. Okay, so the main idea on this is to manipulate the equations manipulate the equations so that a variable cancels right off the bat. And I won't write right off the bat. That's kind of not mathy. Let me just put immediately. So, in this method, the only thing that that's kind of really important before you start is to vertically align all terms. So in other words, like I always like to see something with an x plus something with a y equals the something, and then the equation underneath it, I just want to make sure that I do the same thing. Make sure that the x's are aligned, the y's are aligned, and the normal numbers are aligned. So in the problems I gave you here, that's already happened for you. So this is going to be pretty nice. They're already in the right order. X is in the front, Y is in the middle, numbers in the back. And now we're going to do what this says. Now there's no step by step by step, guys, because manipulate is kind of a vague word. I mean, we can do whatever we want as long as we're fair to every term to manipulate these. And here's what I like to look for. So let's look at these and let's look vertically, okay? In the end, you're going to end up trying to add or subtract these equations, okay? And you want somebody to go away. So let's just kind of look vertically. I've got a 1x and a 1x, right? Okay. Well, if I add these two equations, this is going to become a 2x. If I add these two, it'll be a negative 4y. And so nobody disappeared, right? But if I subtract these two equations, what's going to happen? Well, what's 1x minus 1x? Well, that is a 0x, people. We just canceled out our x's, and that's the goal of this. We want one of the variables to cancel immediately. So I'm going to subtract the equations. So if I subtract top minus bottom, that's gone, but make sure you do it everywhere. So what is negative 5y minus 1y? Well, that would be a negative 6y. And then what is 2 minus 8? 2 minus 8 is negative 6. So this cleans up really fast, because how do I get that y by itself? Well, I just divide by negative 6. And so y is equal to 1. See how much faster that was than what we were doing on substitution? I think it's great. Now, if you mess up, it's because you're going to forget that you're subtracting, and you need to really talk yourself through this minus this, this minus this, this minus this. Otherwise, you're going to mess up a negative or something, so be super careful. Okay, so we're not done though, right? Because remember, the answer is a point, and I've got the y, but I need the x. So how do I get the x? Well, just like the substitution method, you choose one of the equations up here. I'm just going to choose this one just because. And you plug that 1 in for the y. So I have x minus 5 times the 1, because y is 1, I just found it, equals 2. So x minus 5 equals 2. So what number minus 5 equals 2? Well, 7. So I know that my answer for x is 7. And I am finished. Yay! Okay. That's elimination. That's how that works, okay? Now you may be thinking like, well, can it get any harder? Because like that first step, just deciding to add or subtract, that was pretty easy. But what if you can't add or subtract and something disappears, okay? Well, there's actually something awesome you can do to make this one work, okay? So first of all, are they vertically aligned? Yes, X is on top of X, Y on top of Y, number. Okay, we're good to go. Now, just kind of look at it. If we tried to add, that doesn't go away. If we try to add, that doesn't go away. What if we try to subtract? Nobody goes away. Nobody goes away. So what you want to do is, or one of the things you can do, it is perfectly legal to multiply one of the equations by a number so that you can get the number that you want. For instance, let me show you what I'm talking about. Okay, 2 and 3 are hard to cancel. But do you see how there's a positive 2 here? If that were somehow a negative 2, this problem would be awesome. Because if that were a negative 2 and that were a positive 2 and we added them together, what would that make? Well, that would make a 0. So I tell myself, crap, I wish that was a negative 2. Okay, make it a negative 2 by multiplying this equation by 2. And it's legal as long as you multiply everybody by that 2, okay? So what I like to do is figure out my plan, and then I rewrite the equation. So let me go ahead and multiply everybody by 2. So 2 times 2x is 4x. 2 times negative y is negative 2y. 2 times 4 is 8. Yay! Then I recopy the second one because I didn't do anything to it. I didn't need to do anything to it because miraculously now, look at my equations. If I add these two equations together, what's going to happen? Well, the y's are going to cancel because a positive 2 and a negative 2 added together make 0. So those are gone. I need to add these together and I'll have a 7x. Add these together and I'll have, what is that, a 21? Yeah, 21, okay? So if 7x equals 21, now I divide by 7, and x equals 3. So I'm almost done. I know that my x is 3. I still need to find my y, so how do I find my y? Well, you go back to any equation you had up here, okay, and you plug it in. I could plug it into this original, or the new one when I multiplied by 2. It don't matter. Plug it in wherever you want, okay? So let me take that 3, and I'll just plug it into, I don't even know. Let me just plug it into this one since I didn't really mess with it yet. So, 3 times, this x is 3, so plug it in next to it, plus 2y equals 13. 3 times 3 is 9. Recopy the 2y, recopy the 13. I'm trying to solve for y, so let me subtract 9 from both sides. 13 minus 9 is 4, so y must equal 2. Divide by 2, divide by 2. Okay, so that is my solution set for this problem. It's just x is 3 and y is 2. And you could plug them into both to check your answer if you want. I feel pretty confident that these are going to be right. And yay, hallelujah. So you've got all these different methods now, okay? You've got graphing, substitution, elimination. When is the best time to use each method? That is the ultimate question because it's like, oh my gosh, it's overwhelming. There's so many choices, okay? Here's what I do. I always use elimination if the terms are lined up. So if I already see the x, the y, and the number, and this one's the x, the y, and the number, if they're already lined up and I can see that and there's not any work to be done, I always try that first, okay? Substitution, I always try first if you have, so if step 1 is already done for you. So if one equation already has one variable isolated. So an example of that would be like maybe there's an x and a y and a number, okay, on this, but then maybe it's like y equals blah, blah, blah. So if they've already gotten one of the y's by itself or the x by itself, if one of the letters is already by itself in one of the equations, then I use substitution, okay? Now, when do I use graphing? I'm not going to lie. I only use graphing if it's already y equals mx plus b equals y equals mx plus b, and if they're easy to graph. So I don't use it a whole lot. You're going to have to know how to use it, but I don't use it every time. And but if it's already set up like that from the beginning, go for it. So it has everything to do with how it's set up. So if you look at the setup, you'll know which method to use. But I do recommend, know how to do all of them, but then get really good at one of them. And I don't recommend it be graphing, because sometimes there's fractions and it's bad. Get really good at one of these two, and then there is like nothing you won't be able to solve. Alright, cool. So now you're ready to finish off the homework and then check yourself on the solutions videos. For some of you, this is going to be the first week where you are stumped, where you might get stuck, where you might have to rewatch the video. And that's okay. You're not geniuses. You're expected to need more than one repetition. But by all means, please, please do this. This is going to be super beneficial if you learn it now, and instead of having to wait and suffer with the rest of your class next year. All right, good luck doing homework. We'll see you guys later.